All right, we are live today. Good morning, everyone, and a very warm welcome to the third module of the RIB and Geberit seminar series. Thank you, everyone, for joining us this morning. I am Mithuna Murugesh, the RIBA Business Development Manager for the Gulf, and as many of you now know, the RIBA have recently opened one of its first international offices in Sharjah in the UAE. Before we begin today's session, I hope everyone is safe and doing well during this difficult time. As most of the GCC chooses to stay indoors and stay safe during this difficult time, we have now opened up the RIBA and Geberit seminar series to 7 countries across the GCC. Today we have members tuning in from the UAE, Qatar, Kuwait, Bahrain, the Kingdom of Saudi Arabia, the Sultanate of Oman, as well as Jordan. Today's module of the RIB and Geberit seminar series will provide an insight on embedding acoustics into design. Please do send across any questions regarding today's presentation in the chat bar alongside at any point of time, and our speaker today will attend to them in the last 15 minutes Q&A session. Lastly, I would like to thank Geberit for their kind support in sponsoring this seminar series. On that note, I would like to introduce Louise Pitt, the Marketing and CRM Manager for Geberit International Sales, to introduce us to our speaker today.
Good morning and a very warm welcome to all our attendees from the Geberit team in the Gulf region for today's RIBA and Geberit seminar, which, as you learn, is embedding acoustics into design. My name is Louise Pitt, and as you know, I am the Regional Marketing Manager for Geberit. Geberit, a Swiss headquartered multinational, has had an office in the Gulf region for over 20 years, but we've been here for much longer than that, supporting the industry in the Gulf since the 1970s from our Swiss headquarters. I would now like to take this opportunity to introduce to you our speaker for today, Remo Hirschi. Remo is a Swiss national. He is 38 years old, who started his professional career in 1996 in the construction industry with an apprenticeship in plumbing technology. He completed his Bachelor of Science in HVAC Engineering in 2012, after which he was engaged as a project manager in a Swiss consultancy firm. 6 years ago, he joined Geberit, and since then he's travelled to more than 15 countries working for Geberit within the MENA region. A year ago, he relocated to the United Arab Emirates to join the team here in the Gulf region, where he heads up the product management and technical sales support teams for the region. So over to you, Remo, please, for the presentation today.
Thank you, Louise. Thank you, Mithuna, for the introduction. And it's a pleasure to be here for the third module of this webinar series. I'm going to share my screen with you. It will take a few seconds until it will be visible. And then we're going to start. I think the screen should be there, and the topic of today's webinar is embedding acoustics into design. And let's have a look into the agenda. As always, we'll have a very brief introduction on the company Geberit, and then we will discuss about what causes noise, and followed by then the importance of acoustics in design, look or discuss a little bit about acoustics regulations, and then we'll give you some inputs from Geberit perspective when it comes to designing with acoustics in mind. Then there is a lot of acoustic data available from all different kind of manufacturers. We will discuss this a little bit, and then we will be already at the end with a short summary, and then as always we'll have a question and answering session in the end. So Geberit is listed in the 6 Swiss exchange stock market since 2012 and included in the Swiss Market Index. We are a European market leader in sanitary products manufacturing with a global presence in more than 50 countries around the globe. We have powerful brands such as Geberit and Twyford as well, and our business model is the push-pull principles with a lot of technical advisors in the markets who create the pull of our Geberit products. Some key figures about the companies. The net sales last year was 3.1 billion Swiss francs, and as mentioned, done in or realized in about 50 countries with 12,000 employees, and we have 29 production sites which mainly are closely located to our key markets. This overview gives you an idea on the corporate values of our company. So in the center we see what leads us as employees with Geberit. We have an integrity, so we maintain high ethical standards based on trust and mutual respect, combined with open and honest communication, or we're looking for having a good team spirit. Modesty is very important, so we are ambitious and we want to be successful, but adopt both individually and collectively modest and unassuming attitudes and behavior. And when it comes to brand attributes, to mention here, we have 5 key brand attributes, which are innovation, partnership, know-how, reliability, and quality of life. And our target groups are like architects, planners, the media, end users, plumbers, showroom operators, wholesalers, and investors. History of the company, very brief. The company Geberit has been founded in 1874 by Caspar Melchior Geberit in the town of Rapperswil, which is located a little bit south of Zurich at the Lake of Zurich. And the first product this gentleman invented was in 1905, the so-called Phoenix. It was the first wooden cistern which was on the market. Then a very important step in 1952 was when from wood it went to plastics, when plastics became the main material of Geberit, and then cisterns have been produced with plastics. Then also other product areas came into the picture, like 1956 the drainage solutions, then 1964 when the cistern solutions went into the wall. So the first concealed cistern is already more than 50 years old, 1964. Then everything, and this is something we will talk about today also a little bit, installation systems, not shower toilets, but installation systems. It will be a great contributor when it comes to acoustics when we talk about entire systems. We have water supply systems. We have a specific water supply or supply system which is for the industrial applications called Geberit Press. And most recently in 2015 Geberit did an acquisition and has now also products in front of the wall. So basically historically Geberit is very well known for its know-how behind the wall, and recently made the step out of the wall into the bathroom with bathroom ceramics. We invest every year around 2.5% of our annual net sales into these different technology areas. In the first modules we have been talking about hydraulics and virtual engineering when we discussed drainage solutions or siphonic roof drainage systems, and today we're going to discuss more about sound insulation. So when we talk about this technology area, it is important to know that Geberit has its own sound laboratory, which is unique in the industry. It's operational since 1997, and it's based next to our headquarters in Rapperswil, Switzerland. And around 1,750 square meter, this sound lab is used to really test realistic sanitary installations and to measure the acoustics for different situations. So we are not only testing single products in this building, we really can set up complete installations over several floors and do testing accordingly. So now let's discuss about the main topic, which is noise. today. So what is noise? Noise generally is seen as seen as positive for primary use. So for example, in cinemas, when we have conversations, when we're going to a concert, when we're listening to music, TV, etc. So all this would be, let's say, classed as positive sound to the people which are involved. However, once the sound is escaping from the primary user's environment, it could be also classified as noise. So for example, if in a household the TV is too loud and then the sound escapes into the neighbor's living room, it could be classified as noise. So noise, if we talk about noise or sound, mainly we talk about unwanted sound. And in our context, it is usually described into two dimensions. First, a sound as sound level or sound pressure, which is measured in decibel, in dB, and also the frequency in hertz, which describes the sound vibrations in the air, or let's say 1 cycle per second. So these are the two main parameters we're using to describe sound or noise. We have decibel, sound pressure level, and hertz for the frequency. Now let's listen to the sound or frequency spectrum of different not of different noise. This will be the next step. I'm already telling you what is coming next, but let's just have an ear on different hertz, on different frequencies we know. So what we could see here on the graph, and also what you could hear, was the spectrum from 0 to 16 kilohertz on the same pressure level, and definitely it matters what kind of So we could list now first the whole, let's say, a part of this of the range of hertz which we as humans can hear, from 0 to 16 kilohertz. And now in the second slide we could hear a bunch of different frequencies which come then with a different sound. And what is the key here? I mean, we need to understand that every individual perceives or colorates different noise with his memories and his feelings. So also when we talk about sound or noise, we need to consider psychoacoustics, which is a branch of psychophysics and involving the scientific study of sound perception and audiology. And humans perceive, or how humans perceive various sounds. So at the end of the day, if we talk about acoustics in building design, psychoacoustics is also playing an important role, mainly in the individual assessment of unwanted noise. Like, for example, if we think about our neighbors and they're having a shower, if I'm in a very good relation with my neighbor, we meet up together having barbecue or whatever, and then I'm living in a building and I unfortunately hear my neighbor having a shower, then I know, okay, my colleague is having a shower, not really a problem. But let's imagine we're not really in a good relation with this neighbor. There was like a dispute or whatever, I don't know, could be. So we are already a little bit negative when it comes to that neighbor. And then when we hear, on top of that, we hear him having a shower, then probably we will be a little bit more annoyed, feeling disturbed by this person. Just like an example of when it comes to individual perception. And also the different sounds we were listening to definitely gave you a different feeling. Like we could hear the noise of a dentist. Maybe if you have a memory of a dentist visit, then it was a little bit an unwanted noise, like what is this kind of noise? If you're listening to loud music, then it's maybe enjoyable because it's the kind of music we like. So it's very important really to state that it is really an individual perception from person to person. Furthermore, this slide will help us a little bit to visualize the different frequencies we can hear as humans. We will demonstrate some of them. And generally audible sound is within 16 Hertz to 20 kilohertz. This kind of bandwidth, the human ear, but the human ear is better able to hear higher frequencies with the most sensitivity occurring around 2 to 3 kilohertz. So for example, some species have much better hearing than humans. Dogs or dolphins, for instance, can hear much higher frequencies, like up to 160 kilohertz. So it is very unusual for humans to hear frequencies much above 15 kilohertz, as can be seen on the graph. So if we look here on the graph for sound with a lower frequency, generally the sound pressure level needs to be on a higher level that we can hear that. But as mentioned, most sensitive we are here in this area and also on higher frequencies. So I'm going to play here a few of the frequencies, like here we are now on around 100. And we move on. And 10 kilohertz, 15, and 20. So all depending on the age of the humans, this kind of band can change from young years to old years. But generally it's important here to understand that we have only a certain band of sound which we with our human ears can hear. And for as mentioned, for lower frequencies we generally need more volume, let's say, and for higher frequencies we can hear it already even if they are less loud or if there is less sound pressure level. Then a typical question is always, what does the A behind the dB mean? So when we talk about sound, we talk about dBA usually, and this is just the fact that since the human hearing feels different frequencies as different loud, as explained just before, the sound signals are filtered by a sound pressure level meter so that the properties of human hearing are mimicked. So we then speak of a so-called A weighting of the sound level, short dBA, and the decibel scale is logarithmic to then visualize the sound pressure level. 0 dBA corresponds to the threshold of hearing, the auditory threshold, and 130 dBA is about the threshold of pain. So a sound pressure meter has built-in filters that state how the human ear perceives sound. And the most common filter which is used is the A filter. So hence the sound level is stated as dBA. When we look to a noise level monitor, we see here on the left-hand side different examples of type of noise, and we have a scale from 0 up and from green, yellow to red, so lower pressure level to higher. And so if you're thinking on a forest, or let's say the bedroom, which is perceived as very quiet, then we need to know that even if we perceive it as quite quiet, there will be always a sound pressure level of around 20 dBA, and what is below the 20 dBA we usually will not notice. So only above 20 dBA upwards, then it will be audible for the human ears. And then it gets up, like communication in an office, it is used generally around 60 to 70 dBA, and then the like traffic of a truck 90 dBA, and so forth. Like already as mentioned, 130, 140 dBA will be then perceived as painful in the ears. This is like if a jet engine is starting with a distance of like 25 meters, so very close, so really loud. And when it comes to what is generally acceptable or not accepted, we see then on the right hand side this kind of graph. As mentioned, below 20 dBA we don't need to discuss this, we will not notice. And then already when we go up to 25 dBA or 30 dBA, it can be occasionally disturbing. And 35 dBA then already usually too noisy or unreasonable. Everything which is above 40 dBA usually is not acceptable. But interestingly, let's say a library, a place which we associate with quiet or silence, has an average dB rating of 40 dB, showing how we perceive sound in different places, and as well how quiet 40 dB actually is. So it's always very relative when we, or again here it also shows us that it's quite relative what is quiet or what is not quiet. It depends where we are, what is the environment, and what is our expectation, for example, also to that environment. Then we have to differentiate between airborne sound and structure-borne sound. And yeah, quite simply, airborne sound is the sound which is spread through the air, so the verbal conversation. I'm talking, my noise is then arriving at the ear of somebody else, and so on. Then we have the structure-borne sound. I think it's clear here with the illustration. Structure-borne sound is spread through the structures, and this is mainly what we then need to look at when we talk about buildings or designing buildings. And the sound arises from within the structure. Then it can be transferred. What we see here, like as an example from number 1, we see the sound source. So we need to focus on what is the source, what is the type of source we are having, and then we have an airborne sound. Let's think on flushing a toilet. When we are standing in front of the toilet, we will mainly hear the airborne sound of the toilet. But if we then think on the neighbor below or the room next door, then there will be a transmission into the structure, so from airborne to structure-borne sound, and then from the structure again it will be released as airborne sound, and these radiations then reach the ear of the receiver. I think that concludes this introduction about what is noise or what causes noise, and now why it is so important when we talk about acoustics in design. In 2014, Geberit has done a survey and a study, and here we can see clearly that 90% of the participants, they don't like wastewater noise, or 90% have been disturbed already by wastewater noise. And that is also quite interesting, 55% of people would pay a little bit more to rent or maybe for a hotel room to reduce the noise. So this topic is relevant when it comes to buildings. But it really depends, and it depends on the volume of the sound, it depends really on the source and the type of the sound. Again, here the individual perception and the memories. And also it depends on what we associate with the sound we are hearing. So again, very relative. So furthermore, noise reduction in hotels and resorts. So here we see from well-known live review, like here from a hotel stay on a popular review website. And as you can see from the review, they thought the hotel was nice and well located, but was let down by poor sound insulation between rooms and very noisy toilets. Or here, even you can find soundproofing among the facilities, so that it's a criteria which is adverted to promote hotel rooms, that there is a soundproofing installation in hotel rooms. But you can see more and more, if you dig a little bit into these review websites, that people are giving feedback on sleep quality then related to noise and to sound. In private homes as well, you can find a lot of articles in the web about this topic, guides how to reduce or what to do, how to improve if you have noisy neighbors. Imagine if somebody is spending millions into a luxury apartment and then he's disturbed by noise. I mean, this can even come to what I know. I mean, from my home country in Switzerland, people are going to court to fight about who is responsible for mistakes when it comes to noise, because yeah, it's also the expectation, high class apartments, and then you want to have your privacy. So reduce the noise means also increase the value. Definitely can play here an important role, because flushing a toilet probably is not the most wanted noise we want to hear from our neighbors. So when it comes to Geberit, definitely we can give you some recommendations what can be done to reduce the noise and to increase the value of the building, of the apartment, of the hotel room, whatsoever. If we have a look to the cost of noise reduction, I'm very brief. We can talk about materials, so using soundproof pipes and fittings, for example, or let's say soundproof products. Then let's say this is more of a moderate investment or a rather low investment. When we then talk about doors and windows, I mean different quality, different type of glazing, the ceilings and so on, then the investment or the volume, the budget position will be definitely on the higher side than when we talk only about pipes, for example. And then when it comes to really floors, walls, ceilings, the big surface within the buildings, then we talk of higher cost investments to reduce the noise. But it's definitely essential to look into that topic from a holistic perspective. Just to, let's say, replace a single pipe with as our only measure against noise will not solve you the general issue, because we will see later on also we really need to look into the complete build-up and the complete system which will be implemented in the building. And acoustic regulations, I think that's, or in Geberit perspective, that's the key or the most important or the fundament which needs to be in place to start talking about acoustics. If we are not having a clear standard, it will be difficult or it will be impossible to classify or to measure and rate, let's say, different noises. So just a small study which I did was like I found the green building regulation specifications, and from like now here when you talk about the UAE, and there we are referring to the British standard BS 8233 of 2014, which is a British standard documents for guidance on sound insulation and noise reduction for buildings, but it's very vague regarding reducing sanitary noise in buildings, with the only reference being noise emission from hydraulic systems, including domestic hot and cold water services, reagent pipework, and soil and waste pipes serving other bedrooms is not to cause disturbance in normal use. So this kind of sentence is, yeah, it's pretty vague. It's not really clear, and I mean in general for steady external noise source, it is desirable that the internal ambient noise level does not exceed the guideline values in table 4. So there is a table. If you look at this table, this shows recommended noise levels for dwellings. The critical rooms have a suggested dB rating of 35 dB between 7 AM in the morning and 11 PM in the evening, with the bedroom having a recommended dB level of 30 dB between 11 PM and 7 AM. Well, first of all, it's already good to define different areas within the building as accordingly with their activity to have different recommended noise levels. But when it comes to the terminology here, it's like desirable, recommended, and as guidelines. So meaning there are no requirements from this document to meet a relevant standard. It really would need to be clear what needs to be achieved, and then also what we need to look into it. It needs to be defined how to measure. I mean, if we look into a bathroom, for example, where do we measure the sound of the bathroom? Is it diagonal in the room below? Is it in the room just straight below? Is it in the room next door? And so on. So in practice, most high-end apartments, like they would try to work towards a 25 dB rating, and for critical rooms such as bedrooms and living areas. And what we have seen in the beginning from the chart, I mean 35 dB is rather on the higher side when it comes to sound. So these guidelines here are quite vague recommendations, and it goes also further, like there is building regulations part E, which also states that for soil stacks passing through noise sensitive rooms, bedrooms, lounges, wrapping with 25 mm of unfaced mineral wool within a plasterboard duct, 15 kg per square meter density, is deemed to be adequate. Again, this is very vague and gives no guidance on noise levels to work to. and not to mention the use of any acoustically optimized products, or even further, it does not really describe us how the acoustic regulations come across. So we need clear standards which are comprehensive, otherwise we do not know what to achieve and how to compare or classify in the end. So designing with acoustics in mind. It is mostly neglected in planning, concentrating more on the building materials and design of the building. And in the region, most installation elements have direct contact with walls and floors. And in this case, like a floor standing toilet or a wall hung wash basin connected to the primary structure. Or if we are looking into the drainage system here, we have cross floor installation, so all the pipes, they're passing through the ceiling into the false ceiling of the room below, which is already a fundamental, let's say, mistake if we want to achieve very high standards when it comes to acoustics. So with the local pipe layout, we transfer already the sound with the pipe, but the source of the noise we transfer into another area, could be the neighbor's apartment, and then we are going to the shaft. So the key is to decouple as much as possible the source from the primary structure so that we can avoid the noise transmission into the building. So wastewater noise is neglected in planning. I mean, generally, if we're talking about cross-floor installations, we then shouldn't talk in the first second about acoustics. We should talk about how to plan the drainage system in a better way to avoid the problem. Then installation elements with the direct contact, this needs to be avoided. And yeah, some drains pipe do not absorb the noise, then this is already specific to let's say change a product that has been shown. Let's take a better product instead of another one. Of course, this is a solution, but we would recommend first let's have a look on the system before just on the single product. So reducing sanitary noise, we need to look from the source and the path, and then in the end also where is the receiver. So really this is the key, to start with the source. What is the noise, where it comes from, how it's transferred within the building, and where are the receivers. This needs to be in our mind. Designing with acoustics in mind, I mean, there can be already some really basic regulations followed. So for example, do not plan a bathroom next to the living room of a neighbor's apartment, for example, what we can see here on the red wall. So this is definitely a layout which will cause an issue, and then we all need to think, okay, how we are going to reduce now this noise. But much better to plan a bathroom opposite of a kitchen, because a kitchen has less requirement when it comes to noise, and it's within the same apartment here in this case. Like this is one, like it starts from the floor layout, and this is, let's say, without any cost. Like if we are planning the layout, we can amend the location of the bathrooms without any cost. The next step is then what we have seen. We can go into spending money on more materials, on etc. Another example is to enclose pipeworks in a duct. So we see here from number 1, 2 to 3, if we're having a pipe which then is already in a duct, it will definitely reduce the spread of the sound, of the airborne sound. And what you can see here with the lines will be the reflection of the noise. If we're going to add, for example, 20 millimeter mineral wool on 2 sides, this will help to absorb more of that sound, and we can even reduce that sound pressure level. So as an example, the drainage pipe would come with the sound pressure level of 50 dBA, and by adding 2 times 13 millimeter plasterboard, we can reduce already, let's say, by 27 dBA. Then we increase the insulation another 10 dBA, and we will result, let's say, on 23 dBA. So definitely look into the design from scratch. Furthermore, here we see the building from a sectional or from a 3D perspective as well, when it comes to the planning, that we are really trying to plan the bathrooms or the critical rooms where we have the sound source above each other and next to non-critical areas. Then we already avoid lots of then discussions further on. Then here, I mean, these are now some examples on different Geberit products which help to design with acoustics in mind, with having, instead of a floor standing toilet, a wall hung toilet with the system behind, which can be decoupled from the primary structure, but only when I'm really then planning my wall accordingly. Also, if I'm putting a concealed system into a brick wall or in a solid wall, then in the same time this will do sound transmission like a floor standing WC. So there is a lot of possibilities from a product level perspective, but this will not be the problem solver. We need to go one step further. But definitely, when we look here onto that picture, it's a snapshot from the acoustic laboratory when we have a wall-hung WCs installed in a different way. So the system can be into the wall directly. It can be in a pre-wall on a ledge wall, like a ledge wall, like on a part high level, or it can be integrated into a room high pre-wall. So here, definitely, I have a good actions I can implement to reduce the problem, which is known practice. But then the execution is very critical. So a toilet, for example, direct on a wall will give you, let's say, 56 dBA. The WC direct on the wall, the acoustic insulation set, 44 dBA. So only that small insulation set, which we have seen, can reduce. And then a toilet mounted on a Duofix system, which is a comprehensive installation system, fully decoupled from the primary structure, will result in 30 dBA, which you see here on the right hand side. And these measures, what we do in our laboratory in Switzerland, these are according to Swiss standards. So we measure in the room diagonal below. So here these toilets are in first floor, and measuring area where these values are coming from are one floor below and diagonal on the opposite side of these WCs, just to clarify that. But you see here, we were talking in the beginning on about 30 dBA, and you see here now already, to achieve that, we need to have a fully decoupled drywall system with integrated flush tank and a wall hung WC to achieve this kind of levels. So you can see that it is quite some planning and effort behind to achieve levels of around 30 dBA. Another factor here we see is about the pipes as well. As mentioned, there are different materials on the market. Geberit has a piping system called Geberit Silent DB20, which is a reinforced polyethylene with more dense material, thicker walled. It's a mix with 20% barium sulfate, and it comes with acoustic brackets, because this is also then very important how we're going to fix the pipes to the wall. If you're having, you can have the best, the most expensive, let's say, pipe system. If you're not going to install that in the right way, if you create some direct contact with your structure, then all this effort is gone. Additionally, you can put insulation if you are in a critical area. But I think now really the key message from Geberit is, if it comes to acoustics, the best solution you can do is to have a pre-wall with acoustic decoupling, which stops the noise from traveling in the wall. So then really here you see you have your primary structure with this, the solid, the weight-bearing walls, for example, and then in front of that you build up a drywall solution which can be decoupled with some insulation all around your structure. Then the piping system needs to be decoupled. You need to have the right brackets properly installed, no contact to the walls, not to have this transmission what we have seen. So it's really about decoupling, and this can be done using stud work and using even then foam pads between the studs and the floor. The wall hung toilet, as mentioned, then will stop the noise from traveling to the floor. So if this is connected to this system, we can also here avoid then the noise. Let's say we need to look into, first we have the flushing of the toilet, then the water is going through the pipelines down the building, and the seat and cover, and then the filling of the system again. So different sources can be much better decoupled from structure with an entire solution. As mentioned, the piping with the right brackets. Now when it comes to practical execution, this is what we often see on the sites, and then even with the best materials, with additional insulation, with good acoustic brackets, if we have not a proper execution, then there is like a lost investment, because the sound will travel over the cement, and we will create so-called sound bridges. Or here, if you have a transmission through the ceilings, if there is not a proper insulation around the pipe, which is really separating the primary construction with our technical installation, then it's not worth it to have products from a higher grade when it comes to acoustics. So all this cement here is reducing the effect, in the case of the bracket, the effect of the rubber. And it's really essential that the installation is installed in an acoustically optimized way too. Then when it comes to planning, here another example of a drainage system. If I need to plan an offset, I mean, ideally I can plan, it also, this is related to what we have seen before. If I can plan the bathroom all above each other, or the duct as straight as possible from top to below, I will have a straight pipe. I can put it in a duct, add some insulation on two sides, use the proper brackets, and then I'm quite fine. If I cannot, then I need to have a small deviation. If I use 45-degree bends, this will have an impact here. So yeah, you see with the color, the more yellow, orange to red the color goes, the louder will be the noise of an offset. I can put then 30-degree bends or even 50-degree bends if possible, if I'm having the space. So also here, then these are small adjustments to reduce the impact of the noise. I think now we look a small movie when it comes to Geberit.
Quiet, please. How to reduce annoying noise in sanitary installations. Switzerland, home of Geberit, the European market leader in sanitary technology, and home of a world-famous musical instrument, the Alphorn. Sounds great, doesn't it? So what's the difference between a good sound and a bad noise? Well, it's complicated. The quality and volume of the sound are important factors, of course. Another key factor is location. Something that sounds great in the Swiss mountains can be very annoying in your bedroom. Fortunately, most people don't have Alphorn players for neighbors, but still, the problem is familiar to many of us. While it's unlikely to be an Alphorn, it could well be a drainage pipe. The sound is completely different, but both the Alphorn and the drainage pipe follow the same acoustic principles. It's all about vibrations. The water makes the drainage pipe vibrate. The vibrations are transferred to the air around the pipe, but also to any material that touches the pipe. The waves now travel within the building, not just through the air, but through floors and walls too, which means there's a good chance the waves will reach your ear or your neighbor's ear. The ear sends a signal to the brain, which turns the vibrations into sound or into noise. You could say our homes are full of Alphorns, with one big difference. The sound of a drainage pipe is far more annoying. No one likes the sound of a toilet. But how can we reduce the noise made by sanitary installations? Geberit has 3 good answers to that question. And the great news is, compared to other building costs, these solutions are very inexpensive. Solution number 1 is easy. When planning the house, do consider people and noises. For instance, avoid building a bathroom right above a bedroom if you can. And if it can't be avoided, plan for extra noise insulation. Solution number 2 goes one step further and is extremely effective. Minimize the vibrations by detaching the sanitary installations from the building. Here's what you should do. Place the entire flushing and drainage system behind a pre-wall, and make sure the pre-wall, cistern and pipes have no direct contact with the building. Using a pre-wall also ensures that the drainage pipes are on the same floor. Don't place the toilet on the floor. Install a modern wall-hung toilet. Again, there's good news. Geberit can provide all the products and know-how you need. Finally, solution number 3. Choose the silent drainage pipes from Geberit. In combination with a state-of-the-art pre-wall installation, Geberit pipes lead to an excellent noise reduction. No wonder, in the heart of Switzerland, Geberit runs its own sound lab. As a matter of fact, no one knows more about sanitary noise reduction than Geberit. By the way, Geberit is more than happy to share this expertise with you. So if you're dreaming of peace and quiet at home, ask Geberit.
I think this movie summarized the whole presentation very well. So really the key is to decouple and think in the entire system, first of all, and it starts from planning the building. So why it's so relevant? Because we have some questions. Who guarantees the keeping of regulations who ensures the warranty, or who takes the responsibility for observing the construction cost, and then who coordinates all the trades. What we have seen with these real photographs, what can happen, who is responsible to meet the deadline of the completion. The system approach is also interesting if you look on the trades involved. Like in traditional building, we have, when it comes to the bathroom, we have the plumber, solid wall builder, plasterer, tiler, and again the plumber in the end, he comes to install the bathroom products. So this project needs a lot of coordination. When we have a drywall installation, then we already can reduce one trade. And when we offer a complete solution out of one hand, let's say a sanitary full system solution, then we even can reduce the trades on the site, and everything comes out of one hand from one source, and it will be added value at the end for the customer, because the result can be then really on a much higher level in terms of quality and acoustics. Last subject is about acoustic data. There's a lot of acoustic data available on the market, provided by different manufacturers, and we would like to explain you how Geberit approaches or is handling this kind of topic. There is a standard, the European standard EN 14366, which is measuring of noise generated by drainage pipes in a test stand. And this standard measures laminar flow, not toilet flushing, excluding filling noise and water flow. So it's really a defined installation assembly. The standard clearly tells you, what you also can see here on the picture, what needs to be installed. It can be used to compare different drainage materials, yes, and it's more stringent than previous test standards, yes, but it excludes the filling noise and the water flow within the building, so it's not really a real situation which then is tested. It also gives no real strict rules on how to fix the pipes, and it's not coming also with the realistic room layout. And what you can see here, for example, you measure, or the microphone is 2 floors below, so basically you build up this pipe installation, only first of all you put in water which in a laminar flow, so just a few amount of water. If you flush a toilet, it will be completely different scenario, and also we need to see what we have seen from before. I mean, is it really relevant only to measure 2 floors below? Maybe not. And actual noise levels are also dependent on the ambient noise levels. And here this test setup is just questionable, and we believe it's not a real setup like we find it in our buildings. So it's really a certificate which is not comprising the full system. What Geberit is doing, and we believe that is a much better approach when it comes to testing of acoustics, especially also for drainage system, and we need to look into the whole system. So here on the schematic we see we really have a full build-up with fixtures, water supply pipes, and then most importantly we're going to measure in the room next door or diagonal below. And we give also clear specification on what kind of wall construction we are using, what pipe brackets, the pipe brackets are installed as per technical applications. This needs to be defined, like if we believe if you want to have values on acoustics, then you really need to test a real build-up, how it then will be or how it will look like in the end on the building. So use a realistic installation situation, really the usage of fixtures like WCs, wash basins, showers. This will generate the real noise out from the source, and the whole pipe work needs to be installed as it would be on the site, and it needs to be recorded from behind, below, and diagonally. That will really give you then the real figures. And also measure the loudest phase of the flush, not only the quietest. And compared to the European standard, I think this setup will give you much more realistic results, or it will give you the realistic results. So therefore, Geberit provides acoustic data. We have a brochure which is called Sound Insulation, and on our website international.geberit.com you will find a brochure, and also we publish these acoustic data from really real build-up, real situations. So different build-ups which we then define on our data sheets with all the parameters involved, from the density of the wall, the type of installation, is it a pre-wall, how is the pipe work installed, and so on. And then this is really measured under realistic conditions, described on the fact sheets, and then certified by the renowned Fraunhofer Institute. We give you values, what you can really achieve with this type of build-up. And then we discuss on a complete system, a complete solution, comprehensive, with values which then really also can be achieved. And we will provide obviously detailed results to these fact sheets. So as a summary, we all perceive sound in a different way. That is definitely the case. 90% of people do not like wastewater noise, or when we talk about bathrooms in general. Design with acoustics in mind from the outset, so really from the beginning. That's the most effective. Then regulations and standards need to be very clear, otherwise it will be not possible to discuss or define, classify what we really want to achieve. Not possible without regulations. Respect the different room types. Think about the source, first of all, then the pass and the receiver. Ensure good installation practice. This will be the key on all of your projects. If there is not a good installation practice, the best materials will not help. And ensure that the tests are relevant and really realistic. There is a lot of data, but out of the context of a real installation. And then in the end, I would say if from 1 to 8 everything has been considered, then we would start to talk about really acoustically optimized products. So on that note, I would like to thank for your participation and attention, and we would go then to the question and answering session.
Thank you, Remo, for that presentation. I'm an architect myself, so that was actually very interesting to learn about. At this point, we will move to the Q&A session, which will be limited to 15 minutes. Please submit your questions regarding today's presentation on the Q&A bar on the right if you haven't already, and Remo will be able to answer them. So we do have one question that's come in. Do you have design guidelines to share?
Yes, we have. As mentioned in the end, we have a fact sheet on different installations, and we can find them on our website. We have this brochure, sound insulation, basically, which is available for download, or we have it also as a printout here in our offices. And here we have all information basically discussed today is in this presentation. And we have these specific fact sheets for build-ups, which we have done in the lab, which is available. Yes.
All right, while we wait for a couple more questions, let's give it another minute because I know the session does lag slightly. Actually, Remo, I had a quick question. How thick is the free wall? You know, would it eat up into the open space of the washroom at all?
Yeah, usually a pre-wall will usually is defined by the drainage pipe, which if you have a WC will be of 110 millimeter or 100, and then you have to construct, so you will end up at least on 15 centimeters final wall. And then it depends a little bit how you're designing, if you have your pipe on the same floor, if it's horizontally, or if it goes behind into a duct and so on. It depends a little bit on the layout. But I would say from 15 to 25 cm finished wall with tiling and everything.
I see, interesting to know. So if anyone has any questions at all, please feel free to submit them now. Let's give it a minute because it does lag.
Actually, your question is interesting because it's not always the case that you would say that the pre-wall will eat up your space. If you think on a traditional floor standing toilet, if we would look from a sectional perspective, actually the floor standing toilet and a wall hung toilet with the concealed system in a pre-wall will end up on the same space you're having. And then sometimes you also then create your pre-wall only on a part-high level, like you create a ledge, which even can be, from an architectural perspective, can be used as additional space for putting some flowers or whatever, and then having a mirror on top. So it's not necessarily lost space now on.
True.
Contrary.
Interesting. I don't see any further questions coming in today. Remo, I think you've done a great job explaining today's presentation.
I think the video was very well explaining in the end.
All right, I think we can close today's session since we don't have any further questions. Oh, my apologies. We do have questions coming in now.
Okay.
Can Geberit support us during design stage? In other words, can Geberit review our designs and provide feedback from an acoustic point of view?
Yes, we could do that. Put your email address maybe in the contacts, or approach us. We are in Dubai Design District, or sales.gulf@geberit.com, or just contact myself, remo.hirschi@geberit.com, louis.pitt@geberit.com, and get in touch with us. We are happy to support. Yes.
Perfect. Another question, does the free wall prevent sound? I think it meant pre-wall. Does the pre-wall prevent sound from echoing within the same apartment as well?
Sorry, from into which apartment? Your own apartment. If you're in your own apartment, let's think on the toilet flush. I mean, the sound will be exactly the same, no matter how you install your toilet, or if you are opening your tap with your wash basin, the sound source we cannot change within our bathroom, and basically also is not really relevant for the own bathroom. And I mean, the main noise will be if I activate the flushing, then the noise of the bowl itself. Here we cannot help with the pre-bowl. The pre-bowl is then more for transmission into the structure. But yeah, I would say that's, and we want to avoid the sound transmission into unwanted areas. But usually the bathrooms itself, they are classified as non, how to say, non. I just missed the word, like non-regulated areas, let's say, something like that.
Great, thank you. Someone mentions, thank you very much, very interesting presentation. Great. I don't think we have any further questions coming in. I'll give that 30 seconds again. If you have any questions at all, please feel free to send them in.
Yeah.
All right, I think we can close today's session. Yep, I think we can close today's session. So thank you very much for presenting in the third seminar, Remo. So today
thank you very much for having us.
Absolutely. So today has been the third seminar of our RIBA Geberit seminar series, and thank you for presenting in the last two seminars as well. I would also like to thank our audience spanning across 7 countries in the Gulf today. Thank you once again, Luis and Remo, for the wonderful presentation, and I would like to thank Geberit once again for their kind support in sponsoring the RIBA and Geberit seminar series. Thank you, everyone. We hope to see you at our future events as well. Thank you.